All right, now I'm going to go over the new topic, which is electrical fields. And the symbol for electrical fields is E. Nice and easy, E. Now, this topic is not going to be that bad either. And the reason we care about electrical fields is because that's how the force is being carried between the particles. So I can have one particle and another particle, and this particle is creating an electric field. It's creating an electric field that this particle is experiencing, and the force is being carried over the electrical field. So before I continue, there are two things that I really want you to understand. We have two particles. One particle we're going to label as big Q. So now we have big Q, and big Q is the charge that causes the field. So it's the one that's causing the field. And then we're going to have little q, which is the charge that experiences the force. So imagine it like two people playing baseball. One person is the person that throws or causes the ball to go, and the other person is the one that catches it, that experiences that force that the person of the ball that the person threw. So we have big Q and little q. So now, if I have a particle, or I'm going to make this a bigger particle. This big particle may have a field around it. And I'm just drawing my field represented by dots, but we really represent it by lines. But I didn't get to that part yet. So this is the charge that's causing a field. And then we can, so this is big Q. And then little q could be the charge that we put in this field that experiences that field that this one has created. So we have two equations for electric field. We have an equation for the charge that causes the field, and we have an equation for the charge that experiences the force. So the first equation for electrical field is going to be electric field is equal to this constant times the numerical value of that charge divided by the distance between the two charges. So this is the first equation for the one that causes the field. Now, if we want to look at the electrical field for the one that experiences the force, the electrical field will be equal to the force divided by the value of that charge that experiences the force. So we always have to think about, are we talking about the charge that causes the field, or does the problem ask us about the charge that is experiencing that force? And the key word here is experience when we're talking about little q and using that equation. Now, for electrical fields, you know we have two main types of charges that we've been talking about. We have a positive charge and we have a negative charge. Or the only two charges we have, positive and negative. So for a positive charge, the field always points out of a positive charge. So remember I told you they're really represented by arrows. So for positive charges, the electrical field points out or points away from the particle. And for a negative charge, what do you guys think happens? The field points into the particle. So remember that. And this is when we're talking about positive and negative charges. So the field points out for a proton, and it points in for an electron. So a proton causes a field, so causes, big Q, causes a field that points out. And then an electron causes or experiences a field, or not experiences, but causes a field that's pointing inward. So that's why if I have a proton, and if I have an electron, the electrical field is going to be pointing out of the proton and it's going to be pointing into the electron. So if I were to put a positive and a negative charge next to each other, this is how the electric fields will look if they're next to each other. It's pointing out of the proton and pointing into the electron. So these two main equations. Now pay very close attention to this next part. Now, because this was for big Q. Now for little q, so these are when the field is being caused. Now, if we put, now we're talking about if we put a test charge into an electrical field. So, if that test charge is negative, the force is in the opposite direction as the field. So if that charge that I put in the field is a negative charge, then the force is going to be in the opposite direction as the field, or the field is going to be in the opposite direction of the force. And if that test charge is positive, the force is going to be in the same direction as the field. So if I put a positive charge into an electrical field, the force is going to be pointed in the same direction as that field. So for picture examples, if I have, I want you to look over here. Okay. If I have a big Q, which is positive, so I have a big Q and it's positive, and I have, which way is the field pointing for this one right here? If it's positive, remember, it points out. So it's pointing out. And if I have a little Q, so I put a little Q in this field. Sorry, that's just all my lines coming out. If I have a little Q and I put it within this field, this one's experiencing it. And let's say this is positive, then right here, since this is positive, the force of this Q is going to be in the same direction as this field. So if this field is pointing, when it hits this charge, if it's pointing out, that's going to point in the same direction. So my electrical field is up and my force is up. Now, if I have, let me use red, a negative charge, big Q, and we know that for negative, the field points in. And I put a positive Q in this field, so this is going to be a positive Q. If this is positive, which way is the force going to be? It's going to be in the same direction as the field. If the field's pointing this way, then this force is also going to be pointed that way. Just label this is the force. So the force is also going to be pointed in that way. So remember, now we're talking about little q, trying to figure out which direction the force is going to be in. Now, let's talk about when little q is negative. So if I have a big positive charge, we know that the electric field tells us it's going to be pointing outward. Let's say I have a negative little q. If this is negative, it's going, which way is the force going to be pointed if little q is negative? In the opposite direction. So, if my field is pointing up, the force here is going to be pointed down. Because when this field hits this, it's going to be coming from this direction. So that means this force has to be in the opposite direction, which will be that way. And then now, last one. Let's say I have a negative big Q. So we know the field for negative points in. I'm sorry for my picture skills, y'all. If I put a negative test charge into this field, which way is the force going to be pointed? Still the opposite. So now, this force, since the field is pointing this way into the charge that causes the field, then this force is going to be pointing in the opposite direction. So the force is going to be pointed this way. So these were the 4 scenarios. I'm going to go over this tomorrow in class 2 to help you guys get started. But as a recap, we have big Q and little q. Big Q is the charge that causes the field. Little q is the charge that experiences that force. And then we have these 2 equations. And I'm going to go over examples using these 2 equations too. And when we have big Q, if big Q is positive, the field points out. If big Q is negative, the field points in. And then if little q is negative, the force is the opposite direction as the field. And when little q is positive, the force is the same direction as the field.